You know, when we think of a monster storm, we usually picture insane, record-breaking wind speeds, right? But today, we're going to break down a very different kind of storm, one that's remembered not for its power, but for the absolute mystery it left behind. This is the story of Cyclone Ditwah.
All right, let's just get straight to the heart of the puzzle here. On one hand, you've got the storm itself, a cyclonic storm with winds topping out at just 75 kilometers an hour. I mean, meteorologically, that's pretty weak. But then you look at the other side, the impact. 647 people dead, over $1.6 billion in damage. So how? How does a storm that weak cause that much devastation? That right there is the Ditwah paradox.
So to really crack this paradox, we've got to start with the storm. We're about to see how it wasn't the wind that did the damage, but relentless, unending rain that became the real weapon in this catastrophe.
And let's be really clear about the stakes here. This wasn't just some bad storm. For Sri Lanka, this was the single deadliest natural disaster to hit the country since that horrific 2004 tsunami. That fact alone should tell you something was tragically completely different about Cyclone Ditwah.
Okay, now let's trace the cyclone's path because this is where the clues really start to appear. See, the key to its deadliness wasn't how fast its winds were spinning, but how incredibly slow the whole system was moving across the map. This storm didn't just pass by, it parked itself. It just lingered.
This timeline really tells the story. It forms on November 26 and doesn't fully disappear until a whole week later. But look closely at that period between November 29th and December 1st. After it hits land, it just creeps along the coast of India. For days, it was just sitting there, churning over the exact same areas.
And that, right there, is the absolute key. The storm's slowness was its most dangerous feature. By moving at a crawl, it acted like a giant atmospheric fire hose, constantly sucking up moisture from the warm ocean and just dumping it and dumping it and dumping it over the same spots. That unbelievable amount of rain is what set off the catastrophic floods and the deadly landslides.
So now that we understand the terrifying mechanics of the storm, we have to turn to the consequences. And this is the tough part. This section is all about counting the human cost of that relentless rain. The numbers, well, they're just staggering.
647. That's the official number of people who lost their lives. It's a number that just stops you in your tracks. A stark, brutal reminder of the tragedy that unfolded.
And when you break those numbers down by country, the picture becomes painfully clear. The impact was just overwhelmingly concentrated in Sri Lanka. 644 of the deaths, 183 people missing, and that massive $1.6 billion in damage. India was affected, for sure, but Sri Lanka bore almost the entire weight of this catastrophe.
And the damage just cascaded from there. We're talking more than 6,000 homes completely gone, almost 100,000 more damage, nearly 1.5 million people's lives were turned upside down. A third of the entire country lost power. It was a complete breakdown of normal life on a massive scale.
You know, statistics can sometimes feel a bit abstract, but stories like this one, they make it all too real. Can you imagine being one of 69 people trapped inside a bus as floodwaters are rising all around you? This single rescue in the Anuradhapura district just captures the sheer terror and the incredible bravery of those few days.
But in the face of all that devastation, a huge response started to mobilize. So let's look at how Sri Lanka and the entire international community rallied to bring aid and start that long, hard road to recovery.
The response at home was immediate, and it was huge. Sri Lanka deployed over 25,000 of its own armed forces personnel. These were the people on the front lines, running search and rescue missions, getting supplies to people, and just helping anyone in desperate need.
And the world answered the call. I mean, this is just a quick snapshot, but it gives you an idea of the support that poured in. Countries like Australia, the Maldives, the US, the UK, China, they all stepped up, pledging millions of dollars in aid and critical supplies to help Sri Lanka get back on its feet. India's help was especially significant. They launched a whole dedicated mission called Operation Saga Bandhu, which actually means Friend of the Ocean, a perfect name for an operation to provide rapid, comprehensive aid to their neighbor. And this operation was just immense. It was a true all-hands-on-deck effort.
The Navy shipped in over 1,000 tons of aid. The Air Force flew in supplies, helicopters, and even entire field hospitals. Specialized search and rescue teams hit the ground, and Army engineers worked around the clock to build new bridges and reconnect communities that have been completely cut off.
So we've seen the storm, we've seen the devastation, and we've seen the incredible response. But that leaves one final, crucial question just hanging there. Why did this happen? And maybe more importantly, could it happen again? And that brings us to the connection between Cyclone Ditwah and our changing climate.
This is the key. Scientists with the World Weather Attribution Group studied this storm specifically, and what they concluded was that heavy rain events like this are now somewhere between 28% and 160% more intense, purely because of global warming. It's not a guess, it's an attribution.
And the science here is pretty straightforward. A warmer atmosphere can hold more moisture, and warmer oceans act like high-octane fuel for storms. In this case, the scientists calculated that without our recent warming, the sea surface would have been a full degree colder. That is a massive difference in the amount of energy and moisture available for a storm to tap into.
And that really is the final sobering thought here. Cyclone Ditwah was, on paper, a weak storm, but its impact was absolutely catastrophic. It's a stark warning that our old definitions of what makes a storm dangerous might be totally obsolete. So the real question it leaves us with is this. As our world keeps getting warmer, are we actually prepared for the next weak storm?